The lay shaft gears hadn't been dismantled as there wasn't a need. Only the gear selection mechanism, which depended on a selector fork fixed to a sliding shaft. So with this replaced, next is the output shaft. This has a fail-safe clutch, worm drive and thrust bearing. In this gearbox, gears are fixed to shafts using roll pins, and a good selection of them and a good selection of punches is necessary. With the output shaft and fail-safe clutch in place, a series of domed washers to act as springs to tension the clutch, then an adjuster and a lock nut to go on the end of the shaft if needed. Quite how to measure how much tension was applied to the fail-safe clutch, or get the correct measure, I wasn't quite sure. So I did what felt right and then left it at that, as it can always be adjusted when in place. Then the replacement for the upper cover, in which the moving selector fork shaft slides. Driven by the worm drive is a large drum which has internal teeth, which are engaged with the handle mechanism to give autofeed. Next is the pinion which drives the quill up and down, and the handle mechanism attached to it. Attempts to fit the quill into the gearbox here didn't go very well, so I decided to leave it until it was on the actual drill. Next is a lever mechanism that is pushed if the quill is driven all the way down by the autofeed and is about to reach its limit. This disengages the autofeed and prevents this happening. If this lever mechanism is operated, it has exactly the same effect as manually disengaging the autofeed by moving the handle to the right would have. When the cover was back on the gearbox, then the actual quill could be assembled. First off was to replace the taper roller bearing in the lower end, seen here facing upwards. The race for the new bearing was knocked in using the old race as a drift. So this bearing can go in. The end cap can go back on. Right, that's hand tight. I'll leave any more adjustments until it's in position on the drill. Because the bush that goes in the other end has got a bit of play in it, I'm going to make a new one of those out of some oilite. This is the new bearing, sits in the top. See if I can tap that in. Doesn't seem to want to go in easily. We'll put in the shaft inside to keep it lined up better. Let's try that. Let's try it on there. Try the old bearing on top of it. And see what happens. Hit the shaft. The bearing's in most of the way. We'll try removing the shaft and then knocking the bearing in all the way, now that it's lined up square with the quill. As you can see, the brass bush is almost all the way in. Use a piece of wood. Carry on. Well, the wood won't go any further. A nice little turned piece of wood to fit in the slot, really, to fit in the side, the circumference of this lip. Something like the handle of this hammer. That's it, I think. No, it's still got further to go. I did make a piece to push this out. Maybe it'll push the new one in. Right. As the peg spanner I made up earlier to remove the taper roller bearing end cap had a slight design flaw, I had to make another one. What I hadn't quite realised was that to remove any play here, the thrust bearing on the other end of the shaft has to be in place and has to be pulling the shaft into the taper of the taper roller bearing. That would come later when fitted to the actual machine. Next, reassembly on the actual drill.